You've seen it 100 times, right? The super slick, high-tech crime lab where a single hair solves the entire case in, what, 45 minutes? But how much of that is actual, real-world forensic science, and how much is just, great TV? Well, that's what we're here to do today. Separate the hard facts from the Hollywood fiction.
Come on, admit it. You're watching, you see the clues pile up, you hear the detective's theories, and you're sitting there on your couch thinking, oh, I've got this. It was totally the gardener. Well, guess what? Today is your chance to put that confidence to the test.
So welcome to your very own forensic pop quiz. I've got 5 questions lined up for you that get to the absolute heart of a real investigation. We're not talking about fancy, glowing touchscreens here, just pure, hard science. Let's see how you do.
All right, first up, before you can solve the crime, you have to answer the most basic question of all. Who are we dealing with? It all comes down to finding those unique signatures of identity.
Okay, let's start with a classic. Fingerprints. They're basically the icon of forensic science and pop culture. But do you actually know which pattern you're most likely to find? Take a look at the options. Got your answer locked in?
If you said A, loop, you are absolutely right. It is, by a long shot, the most common fingerprint pattern found on human hands, which means it's also a very frequent flyer at crime scenes.
And we're not talking about a small majority here. Loops account for a massive 60 to 65% of all fingerprint patterns out there. That is a huge number. And this chart just puts it all into perspective, doesn't it? You can really see how dominant the loop pattern is. Those circular whorl patterns, they make up about 30 to 35%. And the arches, well, they're the real rarities, showing up in only about 5% of people. Go on, take a look at your own fingers right now. Odds are you're staring at a loop. Okay, ready for question 2? Let's move from something you can see, like your fingertips, to something hidden away, your frontal sinuses. Yeah, those little air pockets in your skull right over your eyes. Why on earth would they be important in forensic identification? And the answer is A. Just like a fingerprint, the exact size, shape, and pattern of your frontal sinuses are completely unique to you. It's almost like a secret signature hidden right inside your own head. Now, here's the really cool part. The whole reason this works is that if investigators can find an X-ray or a CT scan of a person that was taken before they died, say from a dentist or a hospital, they can compare it to the remains and get a positive ID. It's a fantastic example of how forensics can use these totally unexpected parts of our bodies. And just to be clear, you can't get DNA from them, and they're no good for figuring out someone's age. It's all about that unique shape. Okay, let's move on. We've covered identity, so now let's talk about time. Because after a crime, the clock starts ticking. How do experts read the clues the body leaves behind to piece together a timeline of events? This is a huge one in any crime drama. The detective shows up, dramatically touches the victim's forehead, and says something like, "Body's still warm, he hasn't been gone long." They're trying to figure out the time of death, but what's the actual scientific name for using body temperature to do that? The correct term is C, algor mortis, and if you know your Latin, that makes perfect sense. It literally means the coldness of death. So algor mortis is simply the process of a body cooling down after death, eventually matching the temperature of its environment. But here's the reality check. It's not nearly as precise as they make it seem on TV. The speed of that cooling is affected by everything: the temperature of the room, the person's clothing, their body weight, you name it. So it provides an estimate, not an exact time. And this is where things can get a little mixed up. You've probably also heard of rigor mortis, that's the stiffening of the muscles, and livor mortis, which is the way blood settles and causes that purplish discoloration. Now, they are also super important for estimating time of death, but they're completely separate processes. The key thing to remember is that only algor mortis has to do with the body's temperature changing over time. All right, next question. This one is pretty grim, but it's absolutely critical, especially in fire investigations. How can a medical examiner tell if a person was alive when a fire started? Which one of these clues is the definitive sign that separates a burn that happened before death from one that happened after? The only surefire indicator on that list is A, the presence of soot in the respiratory tract. And there's a very simple, very logical reason for that. Think about it. If there's soot and ash deep inside someone's lungs and airways, it means they had to have been breathing it in. And if they were breathing, they were alive during the fire. It's as simple as that. Now, let's bust a huge TV myth while we're at it. You've probably seen that curled up boxer stance in movies, often used to imply the victim was fighting for their life. That is pure Hollywood drama. In reality, it's just a natural reaction where the heat from a fire causes the muscles to contract and pull the limbs in. No struggle involved. Okay, on to our final section. We are now tackling one of the most difficult challenges in all of forensics, figuring out the age of skeletal remains, especially when the victim was a child. You can imagine why this is so important. When investigators find the remains of a child, figuring out their age is one of the very first steps. It helps them narrow down the possibilities from missing persons files and gets them that much closer to an identification. So, out of these options, which one is the most reliable?
If you said C, dental eruption patterns, you absolutely nailed it. When it comes to determining a child's age from their remains, their teeth tell the most accurate story.
And this table really shows us why. The way our teeth develop and emerge, both our baby teeth and our permanent adult teeth, happens on a very predictable, very well-documented schedule. Other methods, like how long the bones are or whether the plates in the skull have fused, they're just far more variable and way less reliable, especially in young children. Teeth are like a developmental clock. So, how did you do on the quiz? What have we learned today? I think the biggest thing is that real forensic science is so much less about that instant, flashy spectacle and so much more about slow, meticulous science. It's about finding those tiny signatures of uniqueness, whether it's a fingerprint or a sinus cavity. It's about patiently reading the story the body tells after death, and above all, understanding that context is everything. And that really brings us to the final, most important thought. The evidence is always there. It holds the story of what happened, completely and truthfully. But that story is only as clear and as accurate as the human expert who interprets it. So the real question isn't just about what the evidence says, it's about who is making sure that we are all listening to it correctly. Thanks for joining me.